Hi friends, are you ready to begin your journey on distance, displacement, speed and velocity? We'll also talk about uniform and non-uniform motion. Let's learn these concepts in a more exciting and practical way. And at the end of the video, we'll do our top 3 questions on this topic. So get ready to fasten your seat belts. Let's start. Let's say you're traveling like me. How do you practically calculate the distance traveled? What about the speed of your vehicle? How do you calculate the displacement? Is it the same as distance? What about velocity? Is it the same as speed? Hold on, I think we have too many questions here. So let me stop the car. Before we answer all these questions, I think it'll be a good idea to really understand these terms first with the help of a simple example. And then we'll come back to our car example. So I'm going to get off the car and let's take a look at these terms first. Consider this example. Let's say this is the view from the top and your house is here and your friend's house is at the other end of the park there. And there is a road all along the park. Now let's say you travel to your friend's house like this. So along this road and then along this road. So what is the total distance traveled by you? It's going to be this distance plus this distance. Now how will you practically measure it? That's right. You can use a measuring tape like this, but you need a really long one. Now let's say this length is 40 meters and this length is 30 meters. So what is the total distance traveled? It's going to be 70 meters. And distance is defined as the total length of the path traveled. Now how do we calculate your displacement? Displacement is defined as the shortest distance from the initial to the final position. Your initial position is your house and the final position is your friend's house. So what is the shortest distance? That's right, it's going to be a straight line from here to here. So how do you calculate that displacement? Again, you can use a long measuring tape like this, or can you see the right angle triangle here? That's right. So we can apply Pythagoras theorem because the displacement is the hypotenuse of this right angle triangle here. So the displacement is going to be square root of 30 square plus 40 square. So that's 50 meters. And as you can see, it's less than the distance. Now let's say there's a curved path along the park, something like this. And you walk to your friend's house along this curved path. So the question is, what is your distance and displacement in this case? Displacement is easy because it's the shortest distance from your initial to the final position. So it's going to be 50 meters again. But how do you calculate your distance? How are you going to practically measure it and it should be accurate? So one thing you can do is, you can take the help of a rope. So if you place a rope along that curved path as you walk, and then you need to measure the length of the rope, and that will give you the distance. There's one more important difference between distance and displacement. Distance is a scalar quantity, while displacement is a vector quantity. Now, what do these terms mean? Scalar means it has only a magnitude, so only a value, but no direction. And vector quantity means it has both magnitude and direction. So let's look at our example here. When you travel to your friend's house like this, the distance was 70 meters. But there's no direction specified. But if you look at displacement, our displacement has a value of 50 meters. Now what is the direction? From the initial to the final position. So if this is the north in the map, our direction is going to be northeast. So your displacement will be 50 meters in the northeast direction. Let's put distance and displacement on our concept board. Now let's talk about speed. Speed is defined as rate of change of distance. Now whenever you see this word rate, it means divided by time. So the formula of speed is distance by time. Now let's take a look at our example. The distance we had traveled was 70 meters. Now let's say you took 1 minute 40 seconds to reach your friend's house. So how many seconds is that? That's right, 100 seconds. Now let's plug in the values and calculate your speed. So speed is going to be 70 meters by 100 seconds. So that's 0.7 meter per second. So that's the SI unit of speed because it's distance by time. So the unit is meter per second. Now let's talk about velocity. Velocity is defined as the rate of change of displacement. So similar to speed, the formula is going to be displacement by time. Now let's look again at our example. So our displacement was 50 meters and the time is the same, 1 minute 40 seconds. So what is your velocity? That's right, 50 meters by 100 seconds. So that's 0.5 meter per second. So speed and velocity have the same unit, meter per second. So just like distance and displacement were scalar vector pairs, so are speed and velocity. And it's easy to remember. S for speed, S for scalar. V for velocity, V for vector. Now let's go back to our example. The speed we found out was 0.7 meter per second. But there's no sense of direction because it's a scalar quantity. And what was our velocity? That's right, 0.5 meter per second. So what is the direction of the velocity here? It's along the northeast direction. So the complete answer of velocity will be 0.5 meters per second northeast because it's a vector quantity. Now let's say you came back from your friend's house using this path. But this time you didn't walk, you borrowed your friend's bicycle and came back really fast. Let's say in 40 seconds. So let's discuss the physics terms here. What is the total distance traveled by you for your entire journey? That is from your house to your friend's place and back. So the total distance is going to be the perimeter of this rectangle. So that's 40 plus 30 meters and 40 plus 30 meters. So that's a total of 140 meters. That is the total distance traveled by you. Now what is your displacement? So your initial position was your house and that's also your final position because you're back here. So what is the shortest distance from the initial to the final position? That's right, your total displacement is 0 because you're back at your home. Now let's talk about speed. But since our speed is changing, once we were walking and the other time you were riding your bike. So it makes more sense to talk about average speed here. Now speed is distance by time, so average speed is total distance by total time. And what is the total distance here? It's 140 meters. And what's the total time? It was 100 seconds plus 40 seconds. So your average speed is going to work out to be 1 meter per second. Now let's look at average velocity. So similarly, it has a formula of total displacement by total time. But the total displacement here is 0. So that's right, your average velocity is 0 meters per second. Let's put speed and velocity on our concept board. Now let's talk about uniform and non-uniform motion. A body is said to be in uniform motion if it's traveling equal distance in equal interval of time and in a straight line. Let's break down this definition. The first part says equal distance in equal interval of time. For example, let's say a car is traveling 10 meters every second. So the car is going at a constant speed of 10 meters per second. And the second part says it needs to be traveling in a straight line. So the direction is constant. So here we have constant speed and constant direction. And we know that velocity is speed with direction. So the car is basically moving at a constant velocity. And so uniform motion means a body is traveling at a constant velocity. Non-uniform motion is exactly the opposite of uniform motion. So does that mean it's unequal distances in unequal intervals of time? Hold on, that's going to be really confusing. So the time interval needs to be kept same. So non-uniform motion means a body is traveling unequal distances in equal intervals of time. Let's take an example. Let's say a car is traveling 5 meters in the first second, and 10 meters in the second second, and 7 meters in the third second. So can you see that the distances traveled every second are unequal here? So the speed is changing. And in non-uniform motion, the speed is not constant. Let's place uniform motion and non-uniform motion on our concept board. Now that we are done with the concepts, are you ready to solve the top 3 questions on this topic? Coming up for you right now. Friends, try solving these questions and do post your answers and doubts in the comments below. I promise to reply to all your comments as soon as possible. So I'm going to disappear and you pause the video here and give these questions a shot. Friends, I hope the concepts of distance, displacement, speed and velocity are crystal clear to you now. But you must be wondering, how do we practically apply these concepts in our everyday lives? For example, let's say you're traveling to your cousin's house. How do you practically measure the distance you've traveled? What about the displacement, speed, velocity, average speed? I'll be posting a video on exactly this, where I'll be driving around and showing you how to practically calculate these things. So do go ahead and watch this video. And do remember to subscribe to my YouTube channel and follow my Facebook page. Thanks for watching.